So taking quadratics, which have the degree of 2, the biggest exponent's 2, just like this one down here, and trying to factor them, which remember, factor means to break it into simpler parts that are multiplied. You can break a quadratic into two linears that are multiplied together, right? And that's a really neat thing, just like how it's useful to know that 20 is 4 times 5. When we know that, it's easier to multiply 20 to other things because we know what it's made of. So factoring quadratics is easier when a is 1, which we have an example of. But what if a isn't 1? Our other strategy kind of goes out the window. So we need to have an overarching general strategy for factoring any quadratic. And yes, you can use this method when a is 1. That's why this method is really powerful. It's because we could just teach this. So the goal is to factor quadratics when a is not 1, or really when a is 1, using the AC method, which is very strong, very powerful, very easy to apply, and once you practice it, it's easy to get. So let's take a look at it. But before we move on, you probably want to take a look at the factor by grouping video for sure, and definitely take a look at how we factor quadratics when a is 1, although that's not required. So just a small recommendation there, but I really need you to watch and know how to do factor by grouping. So when a is 1, that means that we have a 1 out here. And these are generally easy to factor. So how do you do it? Well, the other video goes into it more in depth, but you start with this, with x and x, and you have to pick signs to go here. Maybe it's minus plus, or maybe it's plus plus. And there's a way to figure it out. C is negative. C is the last number. So when that's negative, this has to be minus plus. And we look at the factor pairs of 32, which there's quite a few. We try 1, we try 2, we try 3, fails. We try to divide by 4. 5 and 6 all fail too. 7 fails, and then 8 works, but we already have 8. So that would be it. And we just test those numbers by plugging them in here and trying them. And there's some general strategy though. So if C is negative, we're going to pick terms that are 4 apart because this number's 4 out there. And that would be this. So I know it's 4 and 8. And I want to pick, since the negative sign won out in the front, I'm going to pick the big number to be negative. So it takes control and makes sure it helps me be confident that the middle term is going to be negative. How do I know what all that's going to look like? Remember, we can multiply these, or what we call FOIL, typically with the acronym, FOIL, first, outer, inner, last. So this would be x squared plus 4x minus 8x minus 32. This combines to minus 4x, and we get this. Okay? So by choosing my 8 to be negative, it ensured that my middle term would be negative 2, because 8 was the bigger number. So that was the one strategy. There's kind of a lot of handwork that isn't on the paper, which I don't like, whereas AC method really lays it down. So yeah, that method doesn't really work very well if A is not 1, because this is no longer valid, because there's got to be a 2 in there if the F in FOIL is going to distribute correctly. So that method that I just showed you, it doesn't really work when A isn't 1. But how would you do it in general? How could you solve any quadratic and factor it? Well, you got to multiply to get AC. And AC, remember this is ax squared plus bx plus c. Normally we look at the factors of c, but for this method we look at the factors of a times c, which happens to be 30. So we look at 30 and we say, all right, 1 and 30, 2, 15, 3 and 10, 5 and 6. Those would be the factor pairs of 30. And what you do is you stick in AC here, which is 30, and B is 13. So you try and figure out which numbers you can use out of these 4 options and add them together to get b. And in this case, it would be these two, because 3 plus 10 is 13. So not only does 3 plus 10 have to be 13, but these had to multiply to 30. And that completes this little puzzle, and that's step 2. And then step 3 is to do the algebra. So now what you do is you replace the middle term with these two. So it's going to be plus 3x plus 10x plus 15. Because, I mean, that's equal, right? It seems a little bizarre to do that. It's like, well, why on earth are you doing that? Well, we know that factor by grouping is incredible at factoring things with 4 terms. So the only thing left to do is factor by grouping. So if we go ahead and take the 2 groups, this has an x in common, this has a 5 in common, and they both have that binomial term, which is perfect. So they both have 2x plus 3. So we can take that out, and we get that. And then we factored it. Let's take a look at more examples. Examples. You can't watch this video and know how to do AC method. You got to practice it a lot. So AC. So I always draw my little template for myself, which isn't too hard to draw. And then this has to equal B. So A times C is negative 18. All right. So the negative sign is always a little interesting, let's just say. B is 7. So I got to look at 18. And 18 is 1 and 18, 2 and 9, 3 and 6. 4 doesn't work, 5 doesn't work. So those numbers are the ones that need to go into here. One of these two, you know. Kind of 3 options. However, we have negative 18. And if I'm looking at 2 things that multiply to get negative 18, yeah, it's going to be like 2 and 9 or 3 and 6, but the sign, is it plus plus? No, because we know to get a negative number, one of your numbers has to be negative and one of them has to be positive, right? So I know there's a negative sign here. So my strategy still holds from the other video, is when you have C as negative, you want to look for a part. You don't necessarily want to look at the ones that add to 7, because that doesn't really work. But if you look at the ones that are 7 apart, it kind of reveals your answer for you. And then you just have to be smart about it and know that the 2 is going to go here and the 9 is going to go here. Right? And then that would work. That completes the puzzle. Okay? So when C is negative, you do a part. When C is positive, you do the regular add to. I gotta come up with a good way to say that so it's nice and simple to understand. But yeah. So what does this do? We solved the puzzle. Now what? Well, you rewrite the middle term. And then it doesn't matter the order you do it. You do whatever you want. And then you do the grouping. So you say, okay, these two, because they have nothing in common as the 4 of them. But if you group them together, they do have stuff in common that you can take out. So they both have a 2x, and these both have a 3. And then turns out that out of this group and this group, they both have 3x minus 1. So there's the answer. Okay. Let's try this one. So we got the template. Don't do factor pairs of 10. Don't do that. Do factor pairs of 90. Remember, it's AC. That's why it's called AC method, because it's A times C is 90. Remember, this is AX squared plus BX plus C. So 90. 1 and 90. Typically, it's like never 1. You never, like, rarely do you ever see problems that use the first one. Because it just results in stuff that's so big. How about 2 and 45, 3 and 30? 4 doesn't work because you can't cut this in half. 5 works. Let's see, 5 times, what would it be? 16? No, 18. Okay. 6 would work too. So now you can kind of see that this can get pretty intense. And 9 works too. And then that'll be it, because then I go to 10 and then I start rewriting, so we're good. We are positive. C is positive. So I like to say add to 23. And I know that 23 is negative, but it'll work itself out. So it seems like this might be promising, but let's fill in the puzzle. So this has to be negative 23, and this has to be 90. So the reason why 5 and 18 are nice is because they multiply to 90, and if they had negative signs, they would add to negative 23. So it turns out that that works, and we do have the flexibility. You are allowed to put signs in those boxes. So this would be the answer here. Okay. So if I do a little rewrite of the middle term, and then I do a little bit of grouping. So these have an x in common, and then these have a 2 in common. Excuse me. 9x. And look, I automatically do it without even saying it, but when you have, remember the factoring by grouping video says if you have a negative on the third term, you need to take out a negative as well, or else it won't match. So that's why I took out a negative 2 and not a 2, was because it guaranteed that these match, because those match and they come out, right? And you get this. Okay. Just another example to look at. One more here. So something I failed to mention too is when you're factoring, you don't want to make it harder on yourself. If there's something that you can take out at the beginning that they all have, that could save you some valuable time, because smaller numbers typically means the problem's going to be easier. So all of these have a 2. They don't all have an 8, and they don't all have a 4. So I think 2 is the largest that they have. But these numbers all are going to get halved, and then signs will stay the same. So basically divide everything by 2, and there you have it. Okay, something much easier for us to factor. So A times C is negative 84, and B is negative 5. So 84, we have to break that down and try and find all the factor pairs. We of course have 1 and 84. We can cut this in half. We get 42. I think 3 works too. 4, we'd have to cut this in half. 21. So let's see, if we divide that by 3, we should get 30-ish. 28. 5 doesn't work. 6 is going to work. Man, I picked a hard example, didn't I? 14 maybe? And then 7 works too, which is 12. And 8 does not work, 9 does not work, 10 does not work. Well, does 9 work? I don't think so. No. Anyhow, I think this is it. It's really pretty tough. So C is negative. So I like to look for ones that are, quote, 10. I'm getting the 10 from right here. 10 apart. Oh, oops. I was looking there. We need to be looking here, don't we? I want ones that are 5 apart. And that brings us down to our last one here. Okay. So that's just the strategy. That's my strategy. If it's C is negative, I'm looking for ones that are this number, B, but without the sign, apart. And that's what helps me when C is negative. So I know this is going to be 7 and 12, but there's got to be a negative sign somewhere because those add to 19, and the negative should go here. So when I factor this guy, I'm going to go ahead and break it apart as... So what am I doing? I'm taking this and I'm breaking it apart into this, which is told to me there. So x is in common between those two. So we got 4x plus 7, and there's a 3 in common. And we have a negative there. So it's smart to take out the negative 3. So cut those in third, we get 4x plus 7, which is what we hoped for, right? And at the end of the day, it's going to look something like this. Certainly a harder question here. Unintended, but a little harder than I expected. But that would be it. In your final answer, you don't need to write those parentheses, but you can if you want to. Okay? So in conclusion, what is the AC method? Well, it's a way to take So AC method goes from right to left. It's saying you're factoring something that has a number out front that isn't 1. And if we go backwards the other way, that would be multiplying. Or if we will, FOIL. Okay? So the main strategy for AC method is to do what? It's to fill in our little template that we had, and then you rewrite b, x, you rewrite that middle term, and then you do factor by grouping. Okay, so I gave you a few examples, but I encourage you to practice more.